This video will serve as a hopefully not too long run through of kind of our understanding of what the atom looks like. So at this point, you've probably been instructed at some point in your life that within an atom there are protons and neutrons and electrons. The protons and neutrons exist in the center of the atom, and then the electrons exist far removed from the center of the atom as kind of an electron cloud. The middle of the atom is called the nucleus. That's where the protons and neutrons hang out, and the electrons are somewhere very far from that. Protons are positive, neutrons are neutral, electrons are negative. Okay? Now, our understanding of the atom and those subatomic particles, it's not something we knew from the dawn of time. It's something that we evolved to understanding over time based on the experimentation of some really amazing scientists. And so my goal with this video is just to give you kind of a general sense of where we've come in order to get us to current day. So originally from the dawn of time, people didn't know atoms existed. They didn't know what matter was made up of. We could study matter, we could study what it did, but since we couldn't see what it was a little like, actually, the concept of elementals that exists in like some video games and some like more, magical type things were original Greek philosophers guessing at what life was made up of. Eventually, Dalton, who was a school teacher, right around 1800, re-brought up the idea of an atom and the idea that matter was made up of some indivisible particle or thing that we couldn't break up or divide. From there, more experimentation was done as technology advanced, and as we started to play with electricity and the fact that we could get light to bend, someone named Thomson, J.J. Thomson, discovered that these electrical rays were really light and tiny and also charged. So he predicted that this atom that Dalton brought up actually wasn't a solid sphere of nothing. It had some kind of negative component to it that was really tiny, kind of like chocolate chips in a cookie. And because the atom was neutral, he predicted that there was a large, massive positive thing too within the atom. So kind of the father of the modern atom was Rutherford, and he came up with something we call the nuclear model. So he was the first person to discover that the atom actually had a really dense nucleus in the center. So he did an experimentation where he shot alpha particles through the atom, and the alpha particles mostly went straight through because they didn't hit the nucleus. But when they did hit the nucleus, the particles shot back at him. He compared it to if you shot a bullet at a piece of paper and the bullet somehow bounced off and came back at you. That's how it felt for him. So he predicted there had to be something very small but very massive in the center of the atom. And then he predicted that it was positive. And then those negative chips that Thomson already found that were really tiny were on the outside. So he made this prediction based on the idea that the negative pieces that Thomson had discovered were small, but his nucleus was really massive. So it had to be the positive part. From there, James Chadwick did discover the neutron, the neutral neutron. So now we've got the protons and the neutrons in the nucleus and the electrons on the outside, right? That's the general structure of the atom. And then there was just one more discovery beyond that, and this is really the one we're going to focus on in our class. Okay, so Niels Bohr, he was working with electricity, same as J.J. Thomson was, like way back in the day. Okay, but what he discovered was they knew light was made up of all those different wavelengths of light, different energies, different colors. And what he noticed was that when you energized a particular atom, they gave off specific lights or specific bands of light, which would mean that there were different energies. So probably you've seen this model before. It's potentially the one you used in bio or before that. We call it the solar system model. And it's the idea that proton and neutron is in the middle in the nucleus, and then the electrons reside on the outside in these orbits, right? Different orbits. And the reason there are different orbits is because electrons exist at different energies. So during Bohr's experimentation, when he energized specifically hydrogen, he got different energy signatures out. He saw red, which corresponded to one energy. He saw yellow, which corresponded to another energy. So he needed to create a model for hydrogen that could account for different energy levels. Okay, so his explanation for this, again, was the solar system model. And the idea with this is that as he energized hydrogen, the electrons got excited and jumped to higher energy levels, which would be like a higher orbit. And then essentially life can't sustain high energy for forever, right? Imagine yourself trying to hold something that's even light, right? If I held this water bottle like this for a minute, no problem. But I held this water bottle like this for the next 5 days and didn't put it down, it would start to be really painful and I would need to drop it. Same with the electron, it jumps up to a higher energy level, but it can't sustain that. So eventually it drops back down to a lower energy level, emitting the energy difference, and that energy we saw as light. So don't overly panic if this video you're like, I don't know what's going on. The goal of this video was just to say the atom as we know it with protons, neutrons, and electrons wasn't something we knew from the dawn of time. It's something that evolved. I'm not asking for you to be responsible for understanding how we discovered protons, neutrons, and electrons, but you will have to understand how Bohr decided there were energy levels. So in class, we'll spend time with this, do a couple of demos and experimentation to show this model, and then from here we'll move on to our current model. So this model that you're looking at, the solar system model of Bohr, is not our current understanding of the atom. We've actually evolved one step beyond this that you probably haven't learned before. So that's it for a very brief overview of the history of the atom. Have a nice night.